AI agents are everywhere now. They book your flights. They write your code. They manage your inbox. But here is the uncomfortable truth. When two AI agents need to pay each other, there is no good infrastructure for that. Ethereum has gas auctions. Solana has unpredictable fees. Neither was built for machines. Exfer does it. Think about what a smart contract on Ethereum actually does. An AI agent wants to call a function and it has to guess how much gas it needs. Guess wrong. The transaction fails, and you lose the fee anyway. Or you overpay by 3 times just to be safe. On Solana, compute units are cheaper, but the fee market is still probabilistic. An autonomous agent cannot plan around randomness. It needs deterministic execution. It needs exact cost before it sends a single byte. That is a fundamentally different design requirement. The narration is already well edited, but the user wants it cut to 3 sentences max. Let me write it. Here's the rewritten narration. Once. Exfer is a permissionless proof-of-work blockchain, written in Rust, built for machine-to-machine commerce. Genesis block March 15, 2026. The same rule that turns independent actors into an economy, currency, contracts, enforcement, applies to autonomous machines as it does to humans. Exfer is the monetary layer for the AI agent economy. The proof-of-work algorithm is Argontoid, the same algorithm used for password hashing, now repurposed for consensus. Each hash requires 64 megabytes of RAM and 2 iterations. That memory requirement is what makes it memory hard. You cannot parallelize your way around RAM. No custom silicon has an advantage here. A standard CPU or GPU can compete fairly. 10-second block time. 4 megabyte max block size. Difficulty retargets every 4,320 blocks, roughly every 12 hours. It is a clean. The smart contract language is called Exfer Script. It is a total functional combinator language. Total means every program is guaranteed to terminate. There are no infinite loops. There are no runtime surprises. The cost of executing any contract can be computed statically before you submit. No gas estimation. No fee auction. An agent knows the exact cost of a transaction before it constructs one DE. That is the key property that makes Exfer viable for autonomous systems. The UXO model eliminates global state contention. Re-entrancy attacks, impossible by design. Here is where it gets interesting for the AI stack. ClawHub is an agent marketplace, and Exfer is natively integrated. Agents listed on ClawHub can discover Exfer automatically. They can receive payments in Exfer, call covenants, settle escrow, delegate keys, all without human intervention. The built-in patterns include multi-sig hash locks, time locks, atomic swaps via hashrate vaults, and delegation schemes. This is not theoretical. The KI ships all of these today. The infrastructure is already running. The emission model is elegant. Base reward, 100 million Exfers per block. That is 1 Exfer unit. Plus a decay component, 9.9 billion, having every 6.3 million blocks. That is roughly a 2-year half-life. The curve asymptotically approaches the base reward. Long-term, 1 Exfer per block, forever. Genesis Coinbase, 10 Exfer to a. Coinbase maturity, 360 blocks before you can spend. Thus threshold, 200 Exfers minimum per output. Simple, predictable, no surprise. Exfer launched 90 days ago. 14 stars on GitHub. 4 forks. Written in Rust. Tokenomics. The synchronization time dropped from 16 hours to 90 minutes, with version 1.80. There's one concern the community raised: mining concentration. One actor briefly held over 50% of hashrate. The protocol does not have anti-concentration mechanisms built in. That is worth watching. But the core design is rigorous. Memory hard proof of work, deterministic fees, total functional contracts. This is what machine-native infrastructure looks like. If the AI agent economy is coming, Exfer is one of the few projects actually building the rails. Watch list. Mine it if you have spare memory-capable hardware. Trace out.